Well, let's go ahead and get started, and any of the stragglers can get caught up with the recorded webinar later on. Welcome to SunWize's webinar today on battery installation, maintenance, and enclosures. My name is Rob Rallo. I am a senior engineer with SunWize Power Battery, and with me, as always, behind the scenes is Errol, who will be helping out with questions and things like that. And also, as always, please ask your questions in the question box, and we will try to get to those at the end of the webinar as we have time. And also, as always, our webinars are recorded and can be found up on our website, usually within about 24 hours or less of the webinar. Okay, let's see. I've been in the off-grid solar business for over 25 years now. I started in 1990, and SunWize has been in the business for over 20 years now, with installations on all the continents. We are a systems integrator, and we do standalone systems, hybrid battery backup, and customized and other types of off-grid systems. We also do component sales and engineering and service. We have manufacturing facilities in New York, Oregon, and a few other locations. We also have our headquarters is in Oregon, and we have sales offices throughout the country. As I said, we're an integrator, systems integrator for off-grid systems, and we do standalone systems. We can do trailer-mounted ones, hybrids, cycle-charged, battery backup, custom modules, component sales, and other types of systems and product. Let's see. Our stuff is also assembled in the ISO 9001 facility. It is pre-assembled and tested, and we do follow IEEE standards. We can do UL 508A upon request. Some of the services that SunWize provides is we can do consultation, technical specifications writings, we can do design and engineering, troubleshooting, site surveys, installation services, trainings, things of that nature. So we can do all kinds of services in addition to providing systems and product. So let's go ahead and get started with today's webinar. Our topic again is on batteries. We seem to be covering that quite a bit recently. And I think it's a very important one. In an off-grid system, the batteries are one of the most important components. It's also nowadays almost the most expensive component. It can be up to 40% of the cost of the system, and it's probably the one that fails prematurely the most often. Solar modules can last between 10 and 20 years or even longer. Charge controllers can last between 5 and 10 years or longer, and the battery should last 5 to 8 years. But we're hearing a lot of stories about batteries only, failing in the first year or two. So again, we're focusing on those, and we've gone over this a lot with regards to sizing of batteries and things like that, charge controllers, charging parameters and things like that. We've covered that in a lot of the previous webinars. This one's actually going to focus on the installation and maintenance and what to do during that installation. And some of the stuff is very simple. It doesn't cost any money to help ensure additional life out of the batteries. We're going to try to cover that today. As well as also to go over the other missing component to all of this, which is the enclosure the battery should be housed in for off-grid applications. So again, batteries should last 5 to 8 years. They should be deep cycle. That's another one. You don't want to be using shallow cycle batteries that were designed for starting applications. You want deep cycle batteries. Ones that are designed for cycling. Off-grid batteries are going to cycle, and hybrid systems are going to cycle even more than standalone systems. Standalone batteries typically only cycle about 20% on average every night. They're going to cycle every day because the fact, the sun goes down every night, at the end of every day, and the batteries have to carry through the night. And a hybrid system, it's even worse because the solar isn't going to support the entire load, so the batteries have to get discharged even deeper before the generator comes in. So again, all these applications are cycling, so you want definitely a good cycling battery for that life. Most batteries nowadays are AGM or gel. You don't see a whole lot of the wet batteries anymore, as they do require a lot more maintenance than the gel and AGM batteries. But because of that, the gel and AGM batteries do require a little bit more sophisticated charging. You don't want to overcharge them or undercharge them. The flooded batteries, the wet ones, can be a little bit more forgiving in that area, whereas the AGM and gels aren't. But both the AGMs and gels, depending upon the manufacturer and the technology of that, they're pretty much about 50-50 in terms of acceptability in these systems. So you would, and I would recommend you check the specs on those batteries as well, because again, some of the AGMs are as good or better than the gels, and some of the gels are as good or better than the AGMs. Again, it depends on the manufacturer and the technology that you use. There are also advanced stuff out there, there's lithium-ion batteries and things like that supposedly have wonderful cycling life. But I will say this, if you're taking proper care of your batteries and you're getting the 5 to 8 years out of those batteries, that's pretty good life. Just how much more do you really need, I guess, is the thing you have to ask yourself, and is it worth that additional cost? Lithium-ion batteries now can be quite expensive, anywhere in the range of 3 to 5 times the cost of a lead-acid battery. So sometimes you have to look at the offset of that initial capital expense versus the maintenance expense later on of replacing the lead-acid batteries, maybe 5 to 8 years down the road. So, and again, you should be getting somewhere around 5 to 1,000 cycles out of your valve-regulated batteries, and that's the 50% DoD. The better ones are going to be more on the 1,000 cycle area, and that 1,000 cycles is what's going to get you around the 5 to 8 years, and that's based on a 5-day autonomy battery, so they're only cycling about 20% per day on average. Okay, so in today's presentation, we're going to go over battery installation, which is going to cover battery safety first. I know we covered that in our last webinar, but again, safety is so important. I want to cover it again. I can never stress that enough. Even the best of us sometimes make mistakes, and the more you think about it, the less chances you're going to make that mistake. As usual, they talk about kind of the repetition with that. The more you think about it, the more you'll be used to that. Some of the tools you'll need, and we're going to get into series and parallel wiring. Very important, especially the parallel wiring. We're going to cover that quite a bit because a simple thing with regards to that, which costs no money, it's just a matter of how you wire up the batteries, can extend the life of the batteries. I'm going to go in that in detail. I'm going to show you some real numbers that actually support that information. And then we're going to go into battery maintenance briefly. I think we covered that before in some of the webinars, but we're going to cover that again. Then we're going to go in the enclosures and talk about enclosures a little bit and specifications behind those. So battery safety, if you look at the photo here, you'll notice that this young lady is holding wrenches and has wrenches on top of the batteries, which are not insulated, which is something you definitely do not want to do. So we're going to talk about some of this in a little more detail briefly. Okay. So although valve-regulated batteries don't necessarily, they have immobilized electrolyte or starved electrolyte such that it's not wet like you would get with a flooded battery. There's still a hazard with that. There's a possibility that acid can still be there. It can leak out of the valve itself that regulates the pressure in the battery if the battery has been pressurized for some reason, if it's been overcharged, something like that, and it had the gas. There can be a little bit of acid with that associated with it occasionally. Not much, but nonetheless, the hazard is still there, so you need to keep that in mind. One of the maintenance things is to check that and to neutralize and wipe off any acid that might be there. We'll talk about that more in maintenance. And again, it's not often, but it can occur. It's not unusual, and that acid should be neutralized. Nonetheless, because of that, you should be careful with that. You should still use rubber gloves and things like that when working with the batteries. We'll talk about that in a minute with some of the personal protective equipment you should have. Rubber gloves are definitely one of those. Okay, so again, safety glasses with the side shields. Obviously, you want to protect your eyes. You don't want any acid to get in those. It can really damage your eyes. Also, a eye wash station is also very good to have just in case it does happen. But hopefully, with the safety glasses or goggles, that won't be an issue. I mentioned gloves. Definitely, you don't want to get acid on your hands. Not good if that happens. And a protective apron, safety shoes as well. Safety shoes, definitely. These batteries weigh a lot. They can be hundreds of pounds, some of them, and you definitely don't want to drop that on your toe. That's going to really hurt and ruin your day. A Class C fire extinguisher. Actually, I just found this one out myself on the Class C. The reason for the Class C is I believe the chemicals used in a Class C fire extinguisher are non-conductive. I didn't realize that, but some fire extinguishers can actually have conductive material in them as part of that. And that conductive powder could short out the battery, making the situation even worse. So that's why they recommend the Class C with a non-conductive chemical in it. Acid neutralizer, as I mentioned, you may have a little bit of that around. So an acid neutralizer could be something as simple as baking soda. Just a regular Arm & Hammer from a grocery store can be used to neutralize lead acid. Let's see, insulated tools. Again, cannot stress that one enough. And if they're not, I mean, if you have regular tools, you can actually insulate them themselves by either dipping them in a insulating rubber chemical, or you can even just simply wrapping them in electrical tape is better than using bare metal. I myself have made that mistake sadly too many times. I've gotten lucky sometimes, and sometimes I've had it, and I went to turn a wrench and it smashed into the other terminal, shorting the positive and negative together. So it is too easy to do, especially working in a tight space in a battery box where you have a metal box around it as well. Just too many hazards with all this metal and too many risks of shorting something out. Really using insulated tools when working on batteries, just cannot stress that enough. No reason not to do it. Again, if you're in a bind, even electrical tape wrapped around a wrench or a socket is going to help quite a bit. And lifting devices when working with batteries that are going to be too heavy for you. Obviously, no smoking ever around batteries, because there's always that potential of the gas. Metal objects, not just watches, can be a problem, especially if a metallic watch. That's one people forget about. Rings are a big one. Always, so you want to try to keep the metal objects off your fingers and wrists. Already mentioned uninsulated tools again. Yeah, not just using them, but also something in your pocket that may fall out onto the batteries, or actually anything in your pockets that may fall out onto the batteries. You may want to avoid that, as well as keeping the top of the batteries clear and dry away from things that might fall on it. That's also going to be important with enclosures. We're talking about enclosures. One function of an enclosure is to keep things from falling on the batteries. And because you want to avoid stuff like this. This is not good. This is what happens when batteries can get shorted out. Okay, again, I mentioned the fire extinguisher. Also, if using a CO2 fire extinguisher, you also want to be careful not to, those can be quite cold, and the thermal stress can actually crack the case, making a bigger mess. So be very careful when using that. Again, if you're using a Class C, that would be the safest thing to do. And never remove or tamper with the pressure relief valve that's in the batteries. Some people think they can remove those and add water to them. You cannot. You do not want to do that. That is very dangerous. It also creates a safety hazard as the acid is now exposed and can get all over the place. You definitely do not want to mess with that. Let's see. Never install a battery in a sealed container. We'll talk about that more in detail as to why. So we'll cover that one. And more, if you're looking for more details on safety, we have a tech note on that. You can also always refer to any battery manufacturer's installation manual. All of them have just a whole bunch of warnings and stickers, very similar to what's on the screen, as to be very careful with the batteries. They do have a caustic acid, which is very dangerous to get in your eyes or on your skin or anything else. You always want to be, again, safer on batteries. Can never stress that enough. Even the best of us can get lax sometimes, and it can be dangerous. So always be cautious around them, as they do pose a possible hazard. Okay, some of the tools that are going to be needed for the installation is a multimeter. Very important all the time, every time at a site, regardless of what you're doing, whether it's an installation or maintenance or anything else, troubleshooting, always having a multimeter there to measure voltage and measure current. Insulator wrenches and screwdrivers, I mentioned that quite a bit, how important that is to have those. Wire strippers and crimpers can be necessary depending upon whether your system has cables that are already crimped on it or not. I don't know. Sometimes you have to make those connections in the field and have to cut the cable to length and crimp a lug on the end in the field. So you might need strippers and crimpers for that, depending upon whether you provided that as part of your kit or not. Flexible wire along with that. I want to stress the flexible wire here a little bit. You do not want to use non-flexible wire with your batteries. They can actually put pressure on the terminals, and over time either cause that terminal connection to leak, you can break the seal with the battery, which could be a hazard and a problem, and or you can even break that off, especially on a smaller battery. You put too much pressure on that, you can actually break the terminal off. So you always want to use flexible cable and wire with your battery. Okay, ring terminals, also again, if you have to make those connections in the field. And electrical tape, useful for absolutely everything, from insulating tools to taping off live terminals to everything else. Just really handy to have electrical tape. I actually keep one in my bag all the time. Even when I go on vacation, I have to laugh. It's just always in my bag with me. And my wife laughed one time. I had a roll of green electrical tape in my bag when we were on vacation. She's like, "What's that from?" I go, "I always have a roll with me." Okay, let's get the installation just a little bit. A couple of things along with safety. Always make sure all circuit breakers are in the off position and fuses removed. So always make certain that everything is off and removed before starting any installation. You want to wire the batteries per the design voltage, following the wiring guide for that. It's going to tell you what should be in series and parallel. You should have a wiring diagram with the batteries for the system for that. Okay, and so you want to make certain that the batteries cables are taken to the appropriate endpoint terminated, whether it be the charge controller, control panel, or some other type of battery parallel distribution box or something like that. Okay, once your battery has been correctly wired, and we're going to get into the series parallel wiring a little bit later, and terminated at the right location, you're going to want to turn the battery circuit breaker on first. The battery circuit breaker should always be the first circuit breaker turned on and the last one turned off, because it is the it's kind of the balance for the whole system. It's the reference voltage that the whole system is using. So it's very important that that is the first thing turned on and the last thing turned off. Okay, and so you're going to turn that on. You're going to use a multimeter to perhaps verify voltages and polarities. Check the power electronics and make sure that the LEDs are on. Everything is good. Whether it be powering an inverter directly or whether it be powering up a charge controller or something like that, just want to check and verify that those things have come on and that they have a proper status before proceeding. Once that is done and everything looks good, then you can proceed with turning on the other devices, like load breakers, solar array inputs, and things like that. Okay, so let's start talking about battery wiring and getting into the series and parallel connections a little bit. You do not want to mix batteries of different age, size, manufacturers, types, and things like that, ever. You just don't. I'll probably be mentioning that quite a bit through here of a couple examples of what not to do. But when that happens, the batteries just do not share the currents directly. They have different internal resistances, especially batteries of different age. Because as batteries get older, the impedance inside them can change. And what ends up happening is that because these batteries have got a different resistance or impedance inside them internally, they will not share the current correctly. And when they don't do that, one string or one battery is going to get used more than the other, causing the entire battery bank to fill prematurely. So you really don't want to do that. It's just it's going to end up costing more money and cause damage to perfectly good batteries down the road. So it's just something you don't ever want to do. Okay, when wiring batteries in series, this is going to increase the voltage, and wiring them in parallel increases the capacity. So again, if you've got like a 12-volt battery and you're going to wire that in series with another battery, that'll give you 24 volts. If you're going to put 4 of those 12-volt batteries in series, it's going to give you 48 volts. The capacity is the opposite. So if you have a 100 amp hour battery, it's 12 volts, and you put a second one with it in parallel, it's going to give you 200 amp hours at 12 volts. Okay, and here is a picture of what you do not want to do. You've got batteries sitting on top of other batteries like that. You don't want to do that. You can see you've got different types of batteries. The gray ones are gel, the black ones are AGM. Actually, in this case, the other batteries weren't even connected. You have all these batteries in here, and all that's being used are the 2 gray ones. So this is an example of what not to do and what a mess it is. Because this was one I had to go out and help troubleshoot because of it wasn't working correctly. And the first time I got out there and looked at this, this is obviously why it's not working correctly. It's a mess. Okay. It is recommended to have no more than 4 batteries in parallel, and depending upon the manufacturers can vary. Some say 5 or 6, some say as much as you want. But But generally, you want to try to keep it around 4 or less. Actually, I'd say just 1 or 2 for the most part. You can go up to 4 if you need to, but you want to try to keep that minimized. If you need to go to a bigger battery, go to a bigger battery. You know, let's say you're trying to use 100 amp hour batteries, and it's a 12-volt system, and once you have 4 of those in parallel, you're up to 400 amp hours, but let's say you really need 600 amp hours. Maybe you should go up at that point then from a group 27 battery to either a group 4D or 8D, which can give you 2 of the 8Ds in parallel would give you around 500 to 600 amp hours. That would get you closer to what you need with only 2 strings as opposed to having to go to 5 or 6. So we usually recommend going to a bigger battery at that point to minimize wiring the batteries in parallel. And the reason for this is the internal, as I was mentioning earlier, internal battery resistance. Even the batteries coming off the same line at the same time, all manufactured together, there's still going to be some minor variance. There's always a minor variance. There's always some tolerance to all this stuff. Nothing's perfect. So because of that, the internal battery resistance of these batteries, it's going to be just slightly off, not a lot, but just a little bit. You're going to find same thing with the wire and the connections and everything. They're not going to be exact. There's going to be just a slight difference there. There just is. And the more you have in parallel, the greater this imbalance could possibly be. So by minimizing the strings, you minimize this risk of imbalance between the batteries, the connections, and things like that. Also, you also create more points of failure, by the way, too. The more connections you have, the greater the points of failure. So you can also reduce that as well. I'm going to ask a quick poll question on this, actually regarding battery cable and length. So why do you need the same, why should you be using the same size of cable, length of cable, and wire batteries together? And let's see, have people voted. Okay, so it looks like, I think everybody's got this one, it looks like. It looks like everybody's got it. That's right, to minimize electrical imbalances, absolutely. So I think everybody's got that one now. That's good. Okay, so let's go to our next slide, which is showing a bunch of batteries. This one's up to 5 strings. Like I said, normally I do not recommend this, but in times sometimes you have to. These are already 8D batteries. These are already the big 250 to 300 amp hour batteries. So sometimes you have to. If you do, you want to try to follow some rules when paralleling batteries to try to minimize these imbalances. We're going to go into those rules in just a minute. One of those is using the same gauge wire and using the same length. It's one of the ways you can minimize that. So I'm glad everybody already realizes that. So we're going to go into that in a little more detail here. Let's see, I already mentioned that the more batteries you have in parallel, the greater the risk that you can have a connection problem. We've already mentioned that. Same size wire and length. And again, that'll help to minimize that imbalance. The other thing you want to do is connect to the opposite corner of the batteries. This one I cannot stress enough. I don't know how many times I see people wiring off the same side of the battery, and it causes an imbalance, and it's a problem. And people don't believe me, and people don't realize it. But I actually have some real data from a customer in the field this time, real numbers that show how imbalanced the batteries got and why you don't want to do this. And they're calling us up, trying to figure out how to balance the batteries. And the first thing I said to him was, just move one of your wires. It's that simple. And this was a diagram he sent me. Now, he also made the mistake of tapping the batteries. It's a 24-volt battery, and he tapped it for 12 volts for something. That's something else you don't want to do either. That will also unbalance your batteries. You really do not want to do that. If you have a 12-volt load for a 24-volt battery, use a DC-DC converter. You really want to do that. That will clearly unbalance your batteries and cause all kinds of issues. But the other thing is you'll notice that all the connections are on the battery to the right. There are no connections to the battery on the left. This is the other way he unbalanced it. The batteries on the right are getting used more than the batteries on the left. And what's interesting is if you look at the voltages at the bottom, the batteries on the left are at a higher voltage than the batteries on the right because they're not being used in the same way and they're not being balanced. If you were to move that negative connection from battery 4 to battery 3 to the same negative post, that would balance that problem and help it. And you'll find that those voltages are a lot closer. I mean, you're off by a half a volt here on a 12-volt battery almost. You're off by 0.4 volts. That's pretty substantial between the batteries. So again, that imbalance can get pretty substantial, and all you have to do to fix the problem is just move the wire. So we're going to talk about that in a little bit more detail, showing you examples of that. Here's an example of how that should be done. You will notice that, again, the positive is on the right, negative is on the left. They're coming off of opposite sides of the battery. That's what you want to do. It's called coming off equal opposite corners. There's a couple other names for it too, but that's the one I usually use, is equal and opposite corners. Wiring batteries in series is pretty straightforward. As I mentioned earlier, just if you only got one string, it's pretty simple. Just put the plus and minus together, and then you have 24 volts. For this one, you have a 25 amp hour battery. You still have 25 amp hours. It's just a 24 volts instead of 12. If you've only got two batteries, paralleling gets a little easier as well if it's at the same voltage. Again, we're still using a 12 volt, 25 amp hour battery. Minus to minus, plus to plus. Notice you're coming off opposite sides of the battery. The negative is connected to the battery on the left, the positive to the battery on the right. And this will give you 50 amp hours at 12 volts. And again, it gets a little more complicated when you start putting more batteries in parallel and in series. Now we have two batteries in parallel and two batteries in series, 4 batteries total. This will give you 24 volts at 50 amp hours for the same 12 volt, 25 amp hour battery. But again, you'll notice that the positive is coming into the battery in the upper left corner, and the negative is coming off the battery in the lower right corner. And again, coming off of opposite corners, that's what you want to balance the battery correctly. Okay, talk about battery maintenance briefly. It should be done at least once, preferably twice a year. Generally recommend spring and fall. Generally the fall before you go in the winter, and the spring as you're coming out of the winter. So these are usually good times of year to do it. We want to start with a visual inspection. We want to check batteries for any cracks or other damage. Check terminals for corrosion and clean as necessary. You can also provide a corrosion inhibitor like a no-oxide grease or something like that can help minimize corrosion on connections. And this is an example of batteries that have swelled. So sometimes just doing a quick visual inspection can show you something that's not supposed to be there. Those batteries most likely swelled because they probably got overcharged, and it looks like they're missing. It looks like probably the valves failed. So this is exactly what valves are to do to prevent something like that from happening. So if you've got a battery like that, that probably means that the valve had probably failed on the valve regulation. It wasn't regulating like it should. Check battery connections and retighten as necessary. Very important. They can loosen up from thermal cycling. That happens quite a bit, so it's important to always check those and retighten them as necessary. Crimps as well. I've seen a lot of crimps fail over the years. The connections can terminate. They can corrode. The termination points can corrode. I've seen that a lot. They can fail that way. So you always want to check the crimps, make sure they're still tight and they haven't failed. We'll use a multimeter to record the battery voltages, and you're looking for, going back to that slide I showed before, which showed you that the voltages were off. That's not good. Again, one of those is off by as much as 0.4 volts, and that shows you there's a problem. You should be within 0.3 volts in a 12 volt battery. Actually, I'd like to see them be even less than that, to be honest. I'd like to see within 0.1 or 0.2. So if you're off by more than that, there's probably something going on. Your batteries are getting unbalanced, and you should look at that and investigate. Because if it stays that way for long, then you probably have a bigger problem with your batteries, and they're probably going to fail prematurely. And the whole point of all of this, and one of the reasons we've been stressing batteries so much, is to try to prevent premature failure of the batteries, because it's a lot of money. I hate to see people waste money like that. You know, when they're coming out to be almost 40% of the cost of the system, and you're replacing every 1 to 2 years. In 5 years, you have, basically, pay for the system 2 or 3 times over. So we really hate to see that. If you have the luxury of being able to do a capacity test, that's great. But I know a lot of people don't have the luxury of doing that during a maintenance cycle. I mean, a capacity test is a great way to determine how much life the batteries still have, and to see where it is in its cycle life. But again, that's a luxury you may not have in the field. It's difficult to do. It's time consuming and things like that. So if it's not possible, understandable. But if you have the luxury, it's nice to be able to do that. Charge controller. Again, the charge controller is a very important device for charging the batteries. If it's not functioning correctly, if the set points are wrong, or if it's failing, it's going to damage the batteries. So again, you want to check and make certain your charge controller is operating correctly. that the set points are all good, that the settings are good, and that everything's working as it should in order to keep this battery properly charged. Make sure that it's not overcharging the battery or undercharging the battery. Also, you want to record the temperature while you're there, that's so that you can do calculations to check those charge set points. Those charge set points should be temperature corrected. So in order to double check and make certain that it is charging correctly, you need to be able to do some calculations with regards to temperature correction to make sure it is correcting it as it should and that the values are right. Mention cleaning the batteries, checking for corrosion and cleaning off any corrosions there, looking for any acid that may have happened from valves that have opened or something like that. Again, you can neutralize that with a little bit of baking soda, and water is a pretty easy way to do that. Just make sure you clean it thoroughly. You always want to clean it thoroughly when you're done. Use clean water to do that. Just wipe it off. I actually do that, to be honest. I just let you guys know, I actually do it with my car batteries. This is something I do with my car batteries every now and then when they start to get dirty like that. So it's a tip I think everybody should know on that one. Okay, let's talk about battery enclosures for now. We're going to move into that, and I just want to do a brief poll question with regards to that. So the question is, can you place valve-regulated batteries in a sealed enclosure? Since a lot of people think these batteries don't gas much, a lot of people are wondering, well, can you put them in a sealed enclosure or not? And my goodness, okay, I think it's good. We're about 68%. Okay. Looks like almost everybody got that right. As it looks like almost you got that one right. Yeah, you definitely don't ever want to put valve-regulated batteries in sealed enclosures. What can happen is if those were to gas for any reason, charge controller should fail. Something should happen. If they gas at all, you could get a buildup of hydrogen and you could have an explosive situation. It's very rare, but it can happen, and when it does, it's incredibly dangerous. So, as an engineer, you always want to, do things in a worst case type of scenario. So because of that, you always have to have ventilation of some form. And I'm going to talk about if you do need a sealed NEMA 4X enclosure, how do you handle that situation? I will talk about that in a little bit later on when we talk about these battery enclosures and how to do that. But keeping in mind, all enclosures must be vented. There has to be some type of ventilation. There are also many standards on that. I mean, you can look at the NEC for that, but IEEE has several documents with regards to batteries enclosures and stuff like that, and all of them talk about how they all have to be vented in some way, shape, or form. Battery rooms all have to be vented, so they talk about that. You always have to have ventilation. I didn't put the specific IEEE document up here because there are different documents for standalone PV batteries versus hybrid batteries versus UPS type batteries. They have like 4 or 5 different standards for batteries. I didn't want to put them all up here because there are different ones depending upon the application you're using the batteries with, but they all state the same thing, that batteries should be vented to prevent any buildup of hydrogen gas that could occur in a potential fault situation. And again, the venting could be passive. You don't necessarily need to use fans. Some people ask about that. You really don't, and that actually ends up putting a electrical burden on the solar system. So we always try to recommend don't use them. You shouldn't need them. If everything's designed correctly, there should not be any point to have any type of active venting with fans. Should not be needed. Okay, enclosures, features, and functions. This depends on the application and requirements. We're going to talk about those a little bit, but again, they can have different types of features and functions depending on what's needed. Depends on where the battery box is going to be, what it needs to do, the type of system you have, things like that. So there's a whole lot of things to think about and consider when looking at a battery enclosure. They can be designed for indoor or outdoor use, and they may include room for electronics or not. Tie downs may be required for seismic applications. Sometimes they may just be bolted down depending on the batteries. You might be able to bolt them down. And some models can be pole, wall, skid, trailer, ground mounted, and other. So regarding indoor and outdoor, I'm going to talk a little bit about the enclosure ratings. I'm going to stick with the NEMA ratings because that's what we use in the US. There's also IP ratings, which are international. You may see those a lot. There are crossovers between the IP and the NEMA. There are many documents on that, but I'm going to just try to focus on the NEMA ones because, again, this is more what we see in the US. Right now, I'll talk about the indoor types. You have type 1, type 12, type 12K, and type 13. Type 1 is probably the most common, and it's used pretty much just to prevent somebody from sticking their hand in a box, sticking their finger in there and getting electrocuted, or from things falling into the box from above it and stuff like that. NEMA 12 is a little bit more sealed to prevent against more like dust, things blowing in it, and stuff like that, things dripping in it. And type 13 is similar to the type 12. But again, type 1 is the most common, I think, for indoor applications. For outdoor ratings, you've got, normally you hear about type 3, 3R, and 3RX. You may not hear a lot about 3RX, but 3RX is basically the same thing as 3R, except for using corrosion-resistant materials. And that could be stainless steel, it could be fiberglass, or even powder-coated aluminum is considered corrosion-resistant. Aluminum by itself, even though it has corrosion-resistant properties, is not considered X. You have to add the powder coating to it, but powder-coated or anodized. But generally, it's powder coating. Aluminum can be considered corrosion-resistant, so that can have that X rating as well. You'll see the same thing with the NEMA 4. The difference between the NEMA 4 and the NEMA 4X is just that X has that corrosion resistance. So that could be the difference between a painted steel and a powder-coated aluminum or a stainless steel box. The powder-coated aluminum and stainless steel would be considered 4X, but a painted steel would only be considered 4. Both of them are a sealed box. I want to highlight that. They are sealed, and they are sealed to prevent water from getting in it from any direction. So you can spray a hose at it from all angles and directions, and the water will not get in. Okay, type 6 goes even further. It's a sealed box. It's actually designed to be temporarily submerged. You will see it every now and then. You might see a spec for NEMA type 6 on module junction boxes. I don't know why, but module junction boxes, some of them have that high of a rating. I think even some of the microinverters might have that higher rating, actually, because they're out there in a pretty abusive environment underneath the solar modules. And they're installed in different directions, too. So those might be where you might see those ratings. This is just kind of a little comparison with regards to the different NEMA types. They actually, in this one, they actually included the NEMA 4 and 4X with regards to the NEMA 1 and the NEMA 12. So it actually mixed some of the outdoors and the indoors together. Again, this is all non-hazardous. Hazardous ratings are completely different. We're just focusing on the non-hazardous ratings at this point. And again, the key here is the NEMA 1 is for incidental contact, basically somebody sticking their hand or finger in an enclosure, and just falling debris and dirt. Again, just falling. We're not talking about something that could get splashed or sprayed into or something like that. For that, you might want the NEMA 12 rating for indoor use. And for outdoor, NEMA 3R, even though it is what they call the R kind of stands for rain resistant, the idea is that you can have some blowing rain or snow or something like that. But again, this is from a certain angle. I think it's from like 30 degrees or 60 degrees or something like that. It's not from all angles, whereas the NEMA 4 and 4X are from all angles. And at pressure, you can have like a hose blowing at it type of thing. Okay. Indoor enclosures, they can be quite simple actually. Again, you're just looking for stuff to fall on top of it or keep people from putting their hands in there. It could be something as simple when it comes to batteries, just putting on a battery rack with panels attached to it. I've seen that before. I've seen bolted plexiglass panels around and over top of a battery rack, and the rack actually pushed up against the wall. So the back is covered by the wall. You don't have to have anything from underneath, and then on the sides, top, and front, they just put some panels over it, and that could be considered adequate. Again, only to prevent things from falling into it or on it type of thing. So if that's the case, a NEMA 1 can be fine. It may need to be externally vented or not. Depends upon the requirements for that for the batteries where they're housed, if it's housed in another building or not. It also may depend upon the jurisdiction that you're in and what that authority is going to say about that. In most telecom situations, similar to what you're seeing here, that's usually not going to be an issue. Generally, this facility is actually already vented anyway of some form, so generally it may or may not be a problem. This is just kind of an example of a large battery bank installed in a building or shelter. So in this situation, usually additional venting may not be needed and may already have venting for that room anyway. Okay, and also usually in a dedicated room or space like this, usually a separate enclosure is not needed as well. Again, it may depend on the local jurisdiction. They may require it anyway, but a lot of times they do not. So even though you could walk up and say put your hand on some of those things, because it is in a separate room, they may have to have a SunWize authorized personnel or something like that. Because of that, you can get away with not having to have a dedicated enclosure for that. So sometimes no enclosure may be necessary, depending upon the application. Okay, outdoor enclosures need to be a little more severe here. Usually type NEMA 3R is what you're usually going to use. Again, you normally do not want to use NEMA 4 because it's going to be a sealed enclosure. And some applications it may, and I'm going to address that in just a minute. But again, what you're trying to do is you're trying to prevent water from getting in there. You can add filters and screens to prevent dust and insects from getting in there. I know that can be, just having open louvers. Sometimes you can get bugs in there and maybe some dust blowing in. If that is an issue in your location, you can add screens to that. Just grabbing screens using the windows and just tacking that up there can be all you need to prevent bugs from getting in there. And you can also just use some filter as well, some filter material to prevent dust from getting in there. It can be pretty simple. A lot of times you can just take it out and as part of the maintenance and rinse that stuff off or clean it off and put it right back in. Enclosures fabricated from aluminum can really help with corrosion, and then powder coating it can even help even further. Again, a powder coated aluminum can actually be considered NEMA 3RX and can be considered corrosion resistant at that point. Aluminum enclosures also are easier to work with, generally because they're lighter than steel ones. You don't have to worry about the rust with that. So there's a lot of good advantages of going to aluminum over steel with regards to these. Again, there's lighter weight for shipping, for working with an installation on the site, and with regards to the corrosion resistance. Well, there are a lot of good advantages of going to the aluminum over the steel. Okay, NEMA 4X enclosures should only be used in extremely corrosive environments. Like if you're on a platform in the middle of the ocean or the Gulf or something like that, then yes, you're probably going to need a NEMA 4X enclosure. Or if you're even near the coast where you can have salt spray, then that may be needed. Now, the way to deal with that is you have to add breather vents to it. You can add vents to these enclosures that still maintain the NEMA 4X rating, okay? But a lot of these vents can still be a little bit restrictive. So they don't have as they don't allow the gas to flow as freely as they do with, say, a 3R enclosure. So it can be done, and again, you may have to put a whole bunch of these vents in to do that, but it ends up becoming a bigger problem, and generally we recommend avoiding that if you can, just because you still run the risk, even with these breather vents in there, because they do have a restrictive flow to them. A lot of times there has to be a pressure buildup for them to be able to activate depending upon the type of vents being used. Because of that, there still can be a buildup of gas, just a little bit, minor one, but nonetheless, we typically recommend that you try to just go with the 3R if you can. Again, if you're in a situation where you don't have a choice, then breather vents can be added, but just keeping in mind, it's just adding additional cost to the system. If you can avoid it, that's usually the better thing to do. Okay, smaller battery enclosures can be mounted on a polar wall. These are generally can hold up to about 300 to 400 pounds for the most part. Usually don't want to go with too much more than that, as nobody likes to pick that much weight of batteries up and put them on a pole. It's also a whole lot of weight to be having hanging off a pole too. So generally, it's more of a practical limit than anything else is generally why that's done. And that could be maybe for the Group 30 batteries or a couple of the 8D batteries. Generally, once you get a little bigger than that, you're usually going to put them on the ground on some type of pad mounted enclosure or something like that. The enclosures can still be front opening or top opening. Most pole mounted or wall mounted enclosures will all be front opening, but the pad mounted ones can be either top opening or front opening. It just depends on the style that's preferred and the application for which is being used. Yeah, I already mentioned that practical limitations make it difficult to put on a polar wall. And yeah, usually once it's on the ground, there aren't really any limitations with regards to that because you usually got a pretty good foundation or slab underneath it, that's all. So, in conclusion, the battery enclosures, they come in all different shapes, sizes, and materials ratings, and the best one for your application probably just depends on requirements with regards to where it's located, whether it needs to be indoor, outdoor, the size of the batteries that are being put in it. So, if it has smaller batteries, you can put it on the pole or wall. If you have bigger batteries, you probably need to be on the ground. Front opening versus top opening is just kind of a preference there. And again, whether you want to install the electronics in the battery enclosure or in a separate enclosure, just depends on what's preferred. I know generally we usually try to install the electronics with the batteries. A couple reasons for that is one, it just reduces cost. Which is always nice. People always try to do things cost effectively. So having less enclosures is usually more cost effective. The other thing is if you're using a charge controller with the internal built-in temperature sensor, you want to keep that sensor as close to the batteries as possible. And also that also keeps your cable wires shorter. So you have shorter runs between the actual devices. So that means that you're going to have less losses in the wire between the batteries and the charge controller and other devices. So usually there are good reasons for that. The other thing is also because it is all internal, you don't have to worry about the external wires actually getting shorted, cut, gnawed on by a rodent or something like that. So in some cases, actually, when you do use separate boxes, you may want to install an additional overcurrent device inside the battery box, either a fuse or a circuit breaker or something like that, just in case the external wire ends up getting damaged in some way. So a lot of good reasons to try to integrate the electronics with the batteries. So one of the reasons not to is some people, again, getting back to the corrosive environment, some people will put the batteries in a 3R enclosure and then put the electronics in a 4X enclosure separately because they don't necessarily want those electronics exposed to that corrosive environment. That might be one way to have a happy medium between those two requirements of having the batteries in a vented enclosure without having the rest of the stuff exposed to the harsh environment of the salt air or whatever. So that might be a way to address that. So. SunWize has many different enclosures, many different styles. We have pretty much about 7 series of enclosures now, from our F series to our WF series, M, C, E, T, and our UPS line. So we stock many different sizes and types of enclosures. And again, this is just kind of a little cheat sheet chart here of the different models and options for them. We also have, well, it's just again a lot of more information as always on our website with regards to tech notes. Our enclosure catalog should be in a handout on the little side there, along with some other handouts. And of course, our links to our webinars if you want to catch up on some of the webinars you may have missed with regards to the batteries. Our battery basics was the last webinar we had, and we have other ones on battery sizing as well. So if you missed some of those, a great way to get caught up is to go to our website and look at our webinars. And on the tech notes, we just released a bunch of new ones again, and we're always releasing new tech notes, so always check those out. Lots of good information there. And as always, if you think we're missing a topic you're interested in, send us an email. We'd be happy to try to add that to our tech notes. I'm going to go ahead and take some questions now. If we have time, if there aren't any questions, we have time. We also have an online sizing tool to make it easier to select the battery enclosure. We had, like I said, there were like 6 or 7 different lines of options for enclosures from SunWize. So there's a lot to choose from. So we've tried to help you narrow it down by having a little tool where you answer some questions with some pull downs, and it'll spit out the correct model for you for your application based upon the quantity of batteries you have and your needs. So we can get to that. Maybe we can show a little bit of that if we have time. If not, that'll be in our next webinar. Our next webinar coming up, I think, Errol, is that on the 25th of this month, I think? I think it's 2 weeks from today. It's going to be in our online tools. We have online sizing tools and stuff like that, and we're going to cover all of our online tools in 2 weeks for our next webinar. And our next webinar after that, coming up on November 2nd, I think it is, I think sometime in November, is going to be on Electrical Engineering 101 for solar systems. Basically, how do you apply some of the electrical engineering basics? How does that work with solar? And it's going to be kind of interesting to see how some of these rules of electricity apply to solar, and how some of the things you see with regards to batteries and solar cells and some of the stuff come from just the little physics of electricity and stuff like that. So I'm going to try to go over some of the basics of what I call EE 101 or Electrical Engineering 101 and how that applies to solar. So it should be kind of neat for those people that are and a little more of the technical stuff and some of the trying to understand some of the background about how some of the stuff works and why it works that way. So with that said, let's get to the questions.
Thanks, Rob. We got at least 2 questions so far, so I encourage folks, if there are other questions, please put them into the chat box. We'll make sure to get them answered. The first question we have is on an SGIP rebate in California. And this is from Max, and he indicated that that rebate may require a 10-year warranty, I assume, on the battery. And so he was asking if that is a goal in the battery-based system for longevity in California. Rob, I'll let you answer that. I'm not aware of any battery manufacturers that are offering warranties in that time frame, but maybe we've misinterpreted the question, or maybe you can add to it as well, Rob.
I will be honest, I'm not all that familiar with that requirement and what is needed there. I do know there are a couple of manufacturers that do have a prorated 10-year warranty. I know Deca has that on their Energy 2 line, and C&D also has that on their line. I forget which line that is. I think it's their, I'd have to look that one up, but I know C&D has that as well. So there are a couple of battery manufacturers, and they're larger sizes. These are bigger 2-volt cell sizes. They're big batteries that do have that. I'm not certain who else has that out there, to be honest. I'm just not really that familiar with that requirement. And to be honest, I'm not certain I can really answer that question very well because I'm just not familiar with that.
Max clarified that it's actually the installer that has to provide a 10-year warranty, and I would assume that's for the system. Now, if the installer were to purchase that prorated warranty through either a dealer distributor like us, who in turn gets it from MK Deca, and then they pass that on for the system to the customer, then I would assume that's how they ultimately qualify for that rebate. And that's going to be a decision that the installer is going to have to make with the customer and the end user, and also clarify with whoever they're purchasing the products or the systems from, such as a company like us, SunWize.
Yeah, and I don't know what the requirements are there for enclosures. Those are rather large batteries. And the enclosures for those can be quite expensive, so I don't know what's required. Now, people in situations where, you know, if they put them in a room with a sign that says "Don't enter" or electrical hazard or something like that, it may be appropriate or not. I don't know. Again, that's one of those situations where I'm not all that familiar with those requirements with regards to California.
All right, thanks. We got one other question. This is on the fact that having a lot of these complex power electronics within the battery box would be an explosion hazard themselves. Rob, I'll let you answer this as well, but I believe a lot of the specifications and the requirements that we were going over, as you mentioned, Rob, is actually non-hazardous. And that if you were to be placing the electronics within an enclosure in a truly hazardous location rated zone, then depending on the exact hazard rating and what's required, you may need to certify either all the components or the whole system to something like Class 1 Division 2. Is that correct, Rob?
Well, I think there's actually 2 things there. The first thing is that, yes, this is all with regards to non-hazardous location. That is correct. If you were to install these in a hazardous location, you may need to use a certified enclosure for that. The system probably needs to be certified. There's a whole lot of other rules and regulations that are associated with that. But the other thing is that I think what this person's addressing is that is there a risk of these potentially igniting the gas in the batteries? And to answer that question, this is again is if that battery enclosure is vented, the answer is no, there is not. Again, you should not be getting a buildup of gas in your battery enclosure that could be ignited by anything, whether it's ignited by the electronics, from the electronics getting too hot or a spark from a circuit breaker or something like that. If you are in that situation, you have a bigger problem. You should not allow that type of buildup of gas in the enclosure. And again, if you're using a NEMA 3R enclosure, that should not happen. So that's one of the things we're trying to stress here, is that you're trying to prevent that buildup. So if there is no buildup of explosive gas, then there should be nothing that the electronics can ignite, so there should be no issue.
All right, thank you, Rob. Next question. This is a common one that comes up a lot. I'm sure we could spend a fair amount of time on this. Thoughts on insulating enclosures for both extremely hot and cold locations?
Oh, excellent question. I probably should have addressed that, actually. I hadn't thought about that, but that's an excellent question. You know, I've been in both camps actually on that one. You know, there are advantages and disadvantages to each. What ends up happening is that the battery, this is my thoughts, the battery still sees the overall average temperature. So all the insulation does is it kind of helps to kind of take care of the peaks, the highs, and the lows, so to speak, but it still sees the overall average. So if you're looking to help extend the life of the battery, it doesn't really have an effect on that, because the battery is still seeing the same average in the heat. It's just not seeing such a peak or something like that. Same thing in the cold. Although it may help more there, in the sense that, you know, if you get too cold, your capacity starts to reduce. So if you can make the battery about 5 degrees warmer, that may help you a little bit with the capacity losses that occur from temperature derating. So it could potentially help there. But the other thing you have to keep in mind is that these battery boxes are also vented. They're a NEMA 3R, which means there's always air blowing through them, or they're always seeing ambient temperature. So how much the insulation is actually going to help is a whole other question. Is that delta just a few degrees? Is as much as 5 degrees? And does 5 degrees even matter or not? So there's, like I said, I've been on both sides of that one. I'm kind of 6 1/2 dozen the other. Again, at the end of the day, I don't know that it really helps a lot. I don't know that it really hurts a lot either. Again, it's just a matter of you're kind of shifting the average temperature. You're kind of just shaving the peaks off. The average temperature the battery seeing is still the same. And again, with these things being vented anyway, they're always feeling the ambient temperature, at least in the top of the batteries on the exposed part. So even though the sides and bottoms might be protected, there's still going to be some type of thermal loss to the ambient through the top anyway. So again, I'm not certain how much it's going to help or not. And even at that, it's probably only going to help you in cold temperatures, with regards to, you know, it being not having quite so much of a temperature derate, because it's, you know, maybe the battery's only going to be 0 Celsius instead of -5 Celsius or something like that. That's all. But that's a great question.
Here's a question.
People ask that a lot. That's a good one, so I'm glad somebody brought that up, because I kind of forgot about that.
I got a question on that. I got a question on that too, Rob, because I've done systems with active either heating or cooling, you know, for more specialized applications or for when it's really demanded. Do you think insulation will help if you have either active heating or cooling mechanisms installed? If you couple those together, do you get sort of a different synergy?
Well, again, this gets back to, again, the battery should be in a 3R enclosure, and that 3R enclosure basically means that you're going to be seeing ambient. So any active heating and cooling you're going to do is going to be an issue, because it's just going to be lost to the elements. That's the issue. I mean, it's difficult to do. Now, we'll say this: if there isn't, and this gets back to what I was saying before with regards to fan and active cooling or active ventilation, if your NEMA 3R is not adequate, and you are actually getting a buildup of heat in there or something like that, then yes, active cooling or just a fan would be helpful, because you could also be getting a buildup of gas in there as well. So if that's the case, then yes, but hopefully you've got enough of a passive flow of air going through that 3R enclosure that that's not necessary. Again, usually you see this more in a sealed enclosure than you would in a NEMA 3R. Again, maybe you need to punch some more louvers in it or something like that. And again, if you are getting that buildup of temperature, especially with electronics, and that can happen. But generally, what that tells me is that you know, that generally maybe more ventilation is needed. Louvers might be an easier to do that. Just punch some more holes in the box, essentially. If not, you could go to more active mode with fans or something like that. But I always hate doing that, because then that ends up putting a burden, an electrical burden, on the solar system. and that's such an expensive thing. Every time you add an additional watt of load, you add quite a bit of money to the system. So you want to always try to minimize that as much as possible.
Well, the current questions that we have, Rob, we're a little bit over time, so it might be a good time to call it.
Okay, I think that's it. Again, thank you all very much. And our webinar coming up, like I said, in 2 weeks is going to be on those online tools. We'll go into, if you want to know more about the battery enclosure sizing tools we have, we'll be covering that in our next webinar. Thank you all again for your time today, and I look forward to seeing you all on our next webinar. Thank you.
Thanks all.